I'll go over lab 5 really quickly. Pretty basic one. This one's going to be very important for the project. We're going to discuss how to convert numbers. This is a pretty common thing that we do in computer engineering, especially with how computers work themselves. Usually things are done in binary and then converted into hexadecimal, especially because numbers are usually stored or data is usually stored in bytes, which is 8 bits. And so if you write 8 bits, you can express it with just one hexadecimal number, which is why we might use that method of expressing something. And I'll go over an example really quickly after I go over the lab. This lab, I don't know why it says project on this end. Let me see if I can change that. This lab. So this lab is basically meant to help you loop over things. So looping over a string, maybe for example, if you want to store a number, like a binary number as a string, you might be able to loop over it, loop over each character, and then do something to it, look at the value of it. And based on that value, can you start converting? And that's probably what we would want to do. So this program is going to take in some number, hexadecimal or binary, and then output the value in decimal. And one thing to note, let me see if I can share this notepad thing. Let me see. So I'm going to write a number here, let's say, and for binary, we write in front of it as a prefix 0b, and hexadecimal, we do 0x. So let's just put that, just so we can see what's going on. I'm going to write a binary number. I'm going to write 0b, and then I'll group it in 4 because it kind of makes it easy to write. So 1111, 0101, 1011, 0001. Or I could write it like this. Now, this is somewhat challenging to look at and say, well, how do I convert this to decimal? Well, we remember that binary essentially works in powers of 2. So what happens is we look at the first number, which is 1, and we see, is it, this would be our zeros place. So it'd be 2 to the power of 0. So you multiply the number in the binary number by 2 to the power of 0 for the first thing, and then you add it. You're going to have like a summing, you're going to sum everything. So you're going to have a total, and it's going to like count up all of this stuff. So for example, this one, 1 times 2 to the power of 0, 0 times 2 to the power of 1, that's just 0, 0 to the power of 2, 0 times 2 to the power of 3. More interestingly, 1 times 2 to the power of 4, it would just be plus 2 to the power of 4. And then, we've got 2 to the power of 5 here, 2 to the power of 5, etc. And that's how you would convert this. You'd go through every single number, and you would want to do it lowest to highest. So maybe it would be good to reverse this string or something, whichever way is easy for you. And you can do this in any form. Now, one thing that's really important that I didn't really recognize for a long time when I was doing conversions is the relationship between hexadecimal and binary. So hexadecimal uses the numbers 1 through 10, or 1 through 9, 0 through 9, like this, but it also uses A through F. And A represents 10, B represents 11, and so on. So it can actually store 16 values in a single number. For example, FF, and we'll put 0x, is a hexadecimal number. And these Fs mean 16s. So doing it the same way in binary, well, let's take the number. It's just F times, and then it would be 16 to the power of 0 times 1, right? So it'd just be F plus, and since F is actually equal to 16, we can just write 16. And then F times, so F times 16 to the power of 1 should actually just be a 16 squared. Or 15, yeah, you're right. Yeah, that's right. It goes from 0 to 15. My bad. But there's 16 values. That's what I think I meant to say. So should be like this, and then that's how we would give our, get our decimal number. The relationship between hex and binary is also, very useful, as I was just saying. Now, if you know how to convert hex into binary, you could make this lab super easy. All you'd have to do is convert your hex into binary, and then, just have one function that converts all binary numbers. So instead of having like different functions for, I don't know if it actually asks us here. Yeah, so here I think in the program it asks you to do like hex conversions and stuff. But you don't actually have to do that. You can, in your hex conversion, you can call a binary converter. And with that, you can do your whole lab in just one function, even though I know it is asking for four. And the way that you do that is by recognizing, since every hex number can hold up to 16 values, that also means that it can hold up to 4 binary values. And what I mean by that is, for example, if one hex value like f, from 0 to f goes from 0 to 15, how do I express this in binary? Well, binary would be, 0 to not f, but it would be 1, 1, 1, 1, I believe. That's 1 plus 2, that's 3, plus 4, that's 7, plus 8, that's 15, right? So same thing, 15. Now, what this means is that just f can be expressed as 1, 1, 1, 1 because f is equal to 15, and 1, 1, 1, 1 is also equal to 15. And the most important thing to recognize is that every hex value can at most correspond to 4 of these binary values. So if we had, for example, hex in 7, like 7 in hex, let's say 0x7, we would just have to figure out, well, how do we express it in 4 binary values? Well, 7 in hex is the same as 7 in decimal, actually. And how would you express it in binary? You would just do 0, 1, 1, 1. And this is how we do it. So we've figured out like, oh, 7 is the same. This is also equal to 7 in binary and decimal. So if I gave you like a number like this, 0x, let's say 7f30, I'd convert it by looking at each individual hex thing. So since each individual hex corresponds to 4 binaries, all I'd have to do is look, well, what's the first, most significant number in this hex number? Well, it's 7, so I'd write it as 0, 1, 1, 1. That's my first part of the hex value. I'm going to look at f, and then I'm going to recognize, oh, f is just 15. So what is that in binary? Well, it's just 1, 1, 1, 1. 3, well, same thing, 0, 0, 1, 1. That should be same thing in binary. And then 0 in hex, well, corresponds exactly, 0, 0, 0, 0. And then you can just convert this into decimal. Does that make sense? Just let me know if you have any questions about this. Does it say to use a dictionary? Let's see. I don't think it matters unless it specifies somewhere. Let's load. Let me start sharing the lab again. So let's just read it really quickly. Program will provide a menu, It just converts based on the user selection. Does this, okay. Does not make use of existing hexadecimal or binary conversion routines built in the Python language. Instead, use the conversion using your own knowledge. Okay. So nothing about dictionaries there. Program must provide and use the following methods. Each method signature must be matched and must behave as described. So I guess here we'll see. So it just has to take in a digit. It just says decode a single hex digit and return the value. So I don't think that there's any specific way that we want you to implement this, if that makes sense. I think you could do it in any way, even if that means, something similar to what I suggested with like converting hex into binary first, and then using that as your 2 decimal converter. Does that make sense? If that makes sense, then I'll just go over specifically what each function does. Our first function is just going to do kind of what I had just suggested. Maybe if I share my whole screen, it'll be a bit easier. Kind of got a lot of stuff on here though. Hopefully this is visible. Let me get rid of all this. Yeah, so our first function, hex char decode, is basically just going to do what I just specified with converting each one. So for example, if you passed in to this function f, it would spit out 1, 1, 1, 1. And you could use a dictionary for this, or you could use an array matching it, seeing like, oh, if you input an f, it automatically corresponds to this. You can do that if you like. There's no, I guess I don't know if it, maybe this is returning a value in decimals. So you could do that. You could just like say, oh, in a dictionary, f corresponds with 15, a corresponds with 10, whatever. You could do that if you'd like, but it's not required. I mean, technically, I guess you could do a lot of if statements too, but I don't think that's good either. Second function, hex string decode. Well, same thing. I think that you're probably going to want to use the value, or you're going to want to use this first function within this hex string decode. So hex string decode, it's basically going to have a bunch of numbers. So I don't know, f a 1 7. Can you call this method on every single one of these and then somehow tally up the sum of all of these things? And remember to make sure to convert using the 15 powers of 15 like you did in decimal. Or again, if you wanted to, you could just implement 1. So like in the binary string decode, it might be easier to just convert this into binary, or convert everything into binary, and then use that as your basis for your entire lab. Because if you just convert it all into 1, then it might make it easier rather than having 3-way conversions, if that makes sense. I think that we have to re-encode things as hex though, so that might be a bit more challenging. But a dictionary might be a good method, because I guess you can loop through every single every 4 digits of a binary number. So if you look at the first 4, you could say, does this match one of those numbers? Well, what is this? This is what, 5? And since this matches hex 5, well, maybe in your dictionary you've got everything like this. You've got 0 with 0, 0 or 1 and 1, all the way down to f matches with f, right? So look, that might make sense. There's no difference between lowercase and uppercase f. So it's just the letters, and just to be very clear, you've got 0, 1, 2, 3, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. These are 16 different values, but these can also be lowercase if you want. So A, B, C, D, E, F. So there's no distinction between that. Okay, so I think when you have your things passed in to the functions, it might be written with 0x or 0b just to specify the number type. So you're going to want to check 0x or 0b, but it might not. So you might look in your function, like what are the first 2 characters, and if they are this, 0x, then you might want to take them out using some function, maybe a strip function. Same thing with the binary, but if not, then don't do anything to the number. Yeah, and here it also says hex numbers might be typed in lowercase. It says it's common for them to be typed in lowercase, but I don't think it matters. I think the best thing to do is just to convert it all to upper or lowercase, whichever one you prefer, and then try and manipulate things. So I guess let's look. First example, decoding hex. All you're doing is taking the actual value of the hex thing. So you could do this in any way that you want. You don't need to do it in one specific way. But it might be easy for you to convert this into binary and then convert it into decimal. Just because you know that the property of hex is that every single digit in hex corresponds to 4 binary bits. So that might be easy. Here, our second example here shows that we need to make sure that we're making all of our letters, either upper or lowercase. Just if you're using a dictionary, they won't match exactly, because if you store in a dictionary f is equal to 15, then you're going to, if you call lowercase f and try and match it to something in the dictionary, it's not going to pull up because they're technically different. So make sure that you convert it to whichever way that you store it in a dictionary or a list or however else you want to approach this. And yeah, number 2, decoding binary. So that's why I was kind of saying, well, if you want to just make this function the decode binary function, and then implement your decode hexadecimal one based on the decode binary one, it might be easier. And plus, it also, like, you don't have to deal with powers of 16. It might be a little bit harder to understand. I know I definitely struggled to think in hex. It was really hard to think in binary as well at first, but you'll get used to it. But hexadecimal is still a bit challenging. The numbers get really big. Plus, there's letters. It's not very intuitive. So maybe splitting a hex number into a bunch of 4-bit binaries might help. And then you could implement whatever function you make for the second option and then use it in some way or call it inside of your decode hexadecimal function. And you notice here that there's no prefix 0p, so you still need to be able to convert it even if there is no 0p. The next option here has 0p, so you're just going to want to check first 2 characters. If they are there, then just remove them. Yeah, binary to hex. This one might be a little bit harder unless you remember that, as I was saying, every 4 binaries is just a hex. You can look at this example specifically. The first 4 ones, well, that's equal to 15, right? Because if you just ignore the rest of these numbers, just look at this part. Imagine that this 1 is the lowest and least significant bit. Well, that would be just 1 plus 2 plus 4 plus 8, and that gives you 15, and f is 15. That's where you get that. Looking at the next 4 numbers, it's 1, 0, 0, 0, and that equals 8 in decimal, so that becomes 8 in hex. And then the last 4 digits is 0, 0, 0, 1, which is just 1, and that's where this comes from. Hopefully that makes a bit of sense. I know that it could be a little bit hard to understand, but definitely try and do some of this. And once you get used to it, it becomes a lot easier. But it's definitely good to try and tie them all together rather than make different conversions for all 3 ways, because it becomes very cumbersome. And honestly, we like to be as efficient as possible. So that's what I would suggest. Are there any questions about this so far? Feel free to send a message if there's anything that's really unclear about the lab so far. And if there's nothing, I'll be here to discuss if you need help. But I would definitely suggest start working on these functions, but try and approach it in that modular way, converting everything to one number system and then reversing it or whatever, because it will really help you in the lab or the project, sorry. So Luke, you don't have to, but if you think about this, if you start with creating a binary to decimal function, or so binary to decimal, you could pass in random binary numbers and spit out a decimal answer, right? And if you wanted in your hex function, so hex function, instead of doing, the conversion, with some random hex number like this, instead of doing all those things where you look, oh, f is 15, so you do, 15, or sorry, I guess we have to go the other way. So 8 times 16 plus 9 times 16, or no, I guess this is just 1, sorry. Instead of doing all of this, so making an entirely new converter, right? It might be easier to just, say, oh, well, F is just this 0 or 1, 1, 1, 1, and 1 is just 0, 0, 0, 1. And then, use this binary to decimal function that you've made, right? And then that gives you your answer. Because converting this to binary is actually pretty easy, because you can do it the same way. You would just say 0 is equal to 0, 0, 0. 1 is this. You can do this with the dictionary, on and on and on, down to F is 1, 1, 1, 1. And you could actually use this the other way for your third function. It says convert binary to hexadecimal. Well, if you have the binary values here, then all you have to do is just look at, four values, and then see which one does it match with in the dictionary or whatever method of data structure they're using. Does that make sense? Hopefully that's clear, because this makes it a lot easier in my opinion. Of course, you don't have to, but I think for the project, you have to do something very similar. So I think once you do this second function, if you do it in this method, then you've got a really good base, and then you can actually finish the whole lab just on one function. Your other functions are going to be built around one core function that does all the conversions for you, rather than having multiple converters. So let me know if that makes sense to everyone, and if not, then I'll keep working. I think that you guys can get this done pretty quickly, as long as you just think it through a little bit about why you would do it in this way. But my suggestion is don't make a bunch of those statements. It'll take you a long time. I know I saw that a lot during the temperature conversion one. My method was always like, oh, just convert everything to Celsius and then do the conversions. It's easier to go to one common language, right? And then start translating, rather than, having a separate translator for every single language, one way, two way, three way. It gets really complicated. So hopefully that makes sense to you guys. Any questions about this? Or any other questions about something else, like labs or other labs or projects? Anything not working? And for people who just joined, if you had issues with submitting lab 5, try and submit it again, see if it works. I just changed the auto grader. So hopefully it works. It doesn't let me automatically regrade everyone, but please let me know if there's still issues, because I feel very bad when I wake up and see that no one can submit. So. All right, I'm gonna just put the lab up, and I'll be here to answer any questions. So feel free to unmute or just send a message in the chat and I'll be watching. Oh, by the way, about the exams, we're still grading. I still have a few to get through. I've been out of town for a while. I'm just moving around, so I haven't gotten to everybody. But try and get them in by the end of this week. I know that we said last week, but because of all the holidays, it's just been hard to get everyone in together to discuss. But we're making progress. So if there's any questions about that, just feel free to message. You're talking about project 2B. Let me check. I don't actually know. I haven't looked at this. See if I can check. So I don't really make the projects. I'm always a little behind on what's going on. I think this might be some. Let me check. Okay, so you're referring to runs. So which one are you referring to, Luke? Or which function? Well, I guess it just depends on how you're storing the value. I mean, if you're storing it as, I guess if you're storing it in these arrays, then you should, send an array. But I don't think it matters. I mean, if have a function that's, if you want to pass in an empty, um, if you want to pass in a string, then that's fine, but you just have to implement it in that certain way, or just check for the fact that it is submitted in that way. But it looks like everything is done with arrays, so I would suggest just doing it like that. I don't know. If you have any issues with that, like let me know just exactly where you know, are working on so I can see, because I haven't actually looked at this too much. But I will say that it is very similar. It uses the exact same um, math that you'll do in this lab. By the way, if you don't mind me asking, how do you guys feel like you did on the exam, or just overall, like, do you think the difficulty was too hard or something? Just as a thought, just let me know in the messages because I am curious. So Elizabeth, how's it going? It's nice to see you. I just wanted to let you know for the conversions, if you look here, like everything should be done using our own knowledge of like binary. So, you'd actually want to like see how long is your string of binary values, and then loop over it, and then actually calculate with the powers of two, if that makes sense. So,
Hey,
you
yeah,
know,
so that's exactly what I'm doing, but I actually go through and I say like 2 to the 0 times 1, 2 to the yeah, 2 to the 1
mhm.
times 1, I don't know. And so just go through and do that. But so what I do is I convert the say 1010 each of those to an int. Or should I just completely skip that and just go
I said,
through?
oh, so you're just saying like changing it from like a string so that you can do the calculation.
Yeah,
Right.
absolutely. I'm not using hex or anything like that for this, if that makes sense.
I mean, I don't think that that's really a major issue. I mean,
Okay, all
if
right.
it's just using it to recognize if it's a one or a zero, then that's perfectly
Yeah.
fine in my opinion.
Okay, yeah, that's all I'm doing. Okay,
Yeah.
thanks.
Okay, no
Thank
worries.
you.
Okay, Antonio, don't think that you were prepared. Well, I'm sorry to hear that. Like I did, I looked through a lot of the questions beforehand and I wanted to make sure, and I don't know, do you feel like some of the preparation questions weren't, accurate to what the exam was like, or how do you feel the preparation was? Do you feel like it was, something that we could have done better? I'd like to hear.
Yeah, I mean, preparation, it was 4 questions if I recall, right? It was just 4
I
practice
think
problems.
I think that there were four questions on the review. I don't know if there were more review questions. There might have been, but yeah, there were only four questions that we went over in this lab.
Mhm. Yeah, and that's what I saw for the review.
Mhm.
But yeah, no, I m- I mainly tried to memorize whatever happened on the solutions for that, and I guess that did not help for the exam
Okay.
itself. But
Okay.
again, I could have used more preparation time. Of course, that's on me. But yeah,
Mhm.
I didn't think would be as difficult as it was
Mhm.
for me, but
Right.
maybe others think differently.
We'll, as I go through and grade it, I'm gonna look through everyone's and just see what people struggled on. I think next exam, I wouldn't stress too much. I mean, there's still, project next exam. For the next exam, we'll try and do more questions, and I think that there was a bit of a rush, with like how how fast some of the questions came on. I mean, it was not to say anything bad about everyone else that I'm working with, but we were in a bit of a rush to get the questions out, which I think we're just going to start earlier next time so that I can actually prepare some more, better, more, better questions that are more accurate to what might be on the exam, especially those writing questions. I think like for the most part, the multiple choice and whatever, like, the first few questions were okay, but I do recognize that it can be hard, especially when you're like trying to predict output and you expect like syntax errors. Like I know when I take programming exams, I look and I always think, oh, there might be something wrong because you don't know every aspect of syntax. And you like, I think you might think too much about it. Um, so I don't know if you feel like that.
Yeah, no, I definitely think that I overthink things sometimes.
Mhm.
So yeah, that
Yeah.
probably happened.
Yeah. Okay.
Um,
Well, yeah. Okay. I think, okay.
yeah, yeah, no. Again, I should have prepared more. Honestly, it's on
Well,
me.
look, we'll see how everyone did overall, and then we'll judge how do we change things because we don't want to make it too challenging. And as obviously, if we see that there was a lot of people struggling with certain things, then we might curve the exam. I don't know. We'll see, but I don't want you to feel like you're getting left behind in a sense because it can be like very discouraging sometimes. But I wouldn't worry too much as long as you recognize like that where your faults are, try and learn from it, but moving forward we will try and give more preparation materials. I'll make like an actual dedicated review rather than just going over the questions that they provided me, because
Yeah,
honestly I don't really know how helpful that was, and I don't think that memorizing Solutions, it can help to some extent, but usually it's going to be so different, and you're like locked into one way of thinking about a problem, and it can be hard, especially when we want to like try and encourage that like problem solving. It's definitely not the greatest thing. So we'll try and work on that for next time.
Yeah, no, I feel that that would be really helpful. Just doing a review. That's not just the questions. I mean, the questions are helpful, but of
Yeah,
course,
yeah.
more than that.
No,
Um,
that's absolutely true.
yeah, no, at the and also before taking the test, I was unfortunately like I was behind a few lectures.
Mhm.
Um, that is at the moment I'm actually still kind of behind on lectures. So far on this lab, and I came in a bit late. So far I just I put the menu,
Mhm.
I have the menu set up for the code.
Right.
So where do I where should I start from here?
So, I mean, I would suggest start. You're talking about Lab 5, the one that we're doing now.
Yes, left 5.
I would suggest just start with the second function. I think that they're here. Let me see. Yeah, so there's a few functions here. I think start with the binary string decoding,
Mm-hmm.
especially because did you like get to the part where I kind of explained like how binary works, or do you know?
I
Um,
I did see you explaining something. I got in, I joined in the middle of you
mhm,
explaining something, and then I saw that you had some code up.
mhm.
Um, but yeah, that's
Well,
I
yeah,
remember.
look, I've got like, I'm just kind of going through examples. Let me just pull
Uh,
it. If you want me to go over like just how to convert binary really quickly. I mean, this won't tell you how to
no,
code it, but
if you don't mind, yeah, I just
um, look, so binary, it's just a way of counting, like decimal, we count 1, 2, 3, whatever.
mhm.
Um, and decimal meaning what? It means deci means 10, right? So we've got 1, 2, 3, 4. Let's see. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right. So there's 10 numbers here. There's 5 here and 5 here. And that's where deci comes from. So we've got 10 digits. And then any number past that has to use a combination of these 10. Now, if we've got something like I don't know, ternary like this, instead of ternary numbers, this would be using 0, 1, 2. We've got 3 different numbers, and then the next number after 2 would have to use a combination of these 3 numbers, or like I don't know, maybe octal numbers. This is also a different type. It basically just represents a different base of how many numbers can we have, right? So after an octal, we've got the value for 8, like the actual corresponding value for 8 here, it doesn't exist. You have to make it out of a combination of the numbers that you have in your set. Binary is just it's bi meaning 2, so it means you got 1 and 0. So the way that you find out how do you like combine these digits um, to represent a number, and especially because we're always thinking in decimal, so it's probably easier to think about converting between decimal in our head and whatever. Well, the way that it works is that since 0 and 1 can only represent 2 different values, the way that we do it is we actually look, how do we do this in decimal? Like, for example, if I have the value 99, right? How do I know this exact value? Like, why, like, how do I know what this represents? Because you've combined 2 single digit numbers, but we know, from just our basic math knowledge, that the way that we figure out 99 is that we do 9 times 10 plus 9. So that's how you know, like, oh, the 10 represents like the place value, right? So this is actually the tens place. And if you had 999, well, you could express this as 9 times 10 to the 2, right? Because that'd be 100. So 9 times 100, which would give you the 900, and then you'd add 99, right? So 9 times 10 plus 9. And I'll write it in this notation just to make it clear, is that these powers of 10 represent the different place values. Like, where does it show up inside of the number? So like this 9 here doesn't have the same value as this 9. Does that make sense? because this is actually representing hundreds place, 900 itself. This is representing 90 and this is representing 9. And when you combine it all together, you get 999.
Okay.
Same thing like when you do binary now. Well, instead of having numbers like 999 or I don't know, like you could have any of these numbers, right? Instead, we can't use all of those digits. We can only use the numbers that we have in our set. So we got 0 and 1. So let's just say our number is, I don't know, 1010. All right, and typically to distinguish between this, it's not 1010, right? We're going to distinguish it by putting a 0b representing binary. All right. And how are we going to do this? Well, it's similar to decimal in that, there are different hierarchies of numbers. So this 0 is not, in a sense, worth the same as this 0. I mean, it's a 0, so technically it kind of is. But for example, this 1 here does not have the same value as this 1. Same way as that this 9 here doesn't have the same value as this 9. Does that make sense so far?
Yeah. So I understand that they aren't the same value. That's what
Yeah.
you're saying?
Yeah, that's good. So we're just going to see like, well, how does this actually tie into what we just did? Well, notice that we said with decimal, there's 10, unique digits, right?
Mm-hmm.
And it makes a lot of sense. We count in 10 because we got 10 fingers. It makes it a lot easier for us. But what about 2? We've in binary, we have 2 unique digits. What do you see this 10 coming into place? We've got, I don't know, I mean, we know that we call this like ones place, tens place, hundreds place, right?
Mm-hmm.
And those are just powers of 10. And that 10 here comes from the fact that there are 10 unique digits. Because in each hierarchy of numbers, so in the tens place, you can only hold, in this spot, you can only hold 0, 1, 2, 3, 4, 5. You can only hold 10 different numbers, right?
Mm-hmm.
So that's why we're putting times 10. And of course, there's 10 unique digits. But in a binary system, we can only hold 2 unique digits. So it would be like 0 and 1, and that's it. So for example, let's say in this spot here, it can only be 0 or it can only be 1. And that means that when we want to multiply it to see like, oh, how many values could there be in that specific spot? Well, there could only be 2, right? In this case, we're multiplying by 10 for decimal because there could be, in this spot here, there could be, 1, 2, 3, 4, 5, 6, 7, 8, 9, and they all represent different numbers. However, here we can only have, 0 or 1. So we can only multiply by 2 because there's only 2 ways to change this number in a specific place. So in the ones place, for example, if I change it between 0 and 1, it's becoming different numbers, but I can't add a 2 because it doesn't exist. So when I actually want to figure out what are the values, I'll do the exact same method that I did here, and I'll write it out more clearly. Ones place doesn't have any 10. So it's 9 times 1, and that's why it's called the ones place, right? And it might be good to think about this as the ones place as well, because in binary, there's only one value that represents if a number is even or odd, and it's the last one because its value is always going to be 1 or 0. So for the
Mm-hmm.
first digit here, well, let's see. Well, what's the actual binary value? It's 0. And then we're going to have to multiply it by 1. It's in the ones place, right? So it would be, and I'll write it as 2 to the power of 0 so you can see the pattern. So that's going to be our first number. It's going to be the smallest number. And I'm going to start adding them to the left just so that we can see it more intuitively. We look at the 1 here. It is not going to be in the ones place, but this could be 0 or 1, and it will change the value of the whole number. So we're just going to put the value that it actually is. It's 1, and then we're going to multiply by all the possible numbers that could be there, and there's only 2 of them. So we're just going to put 2 to the power of 1, right?
Mm-hmm.
So the next number, 0, it could be again 2 different numbers, 0 or 1, but since it's in a higher place, I guess here, we're going to go up in the power. So we're going to do 0 times 2 to the power of 2, because it's in, it might seem a little bit weird, but I think it would make a lot of sense to think about it as 1's place, 2's place, 4's place, because you see that we've got like a 2 to the power of 2. And this might be really weird, but it's exactly what we do with normal decimal, right? We just call it tens place, hundreds place, thousands place. But here, since we've only got two options, we've got 1's place, 2's place, 4's place, 8 places, etc. Because we've got less numbers to work with here. So we have to our numbers are going to be a lot longer and we'll have less places. So instead of having 10, 100,000, it would go 2, 4, 6, 8, 10, or not 10, 2, 4, 2, 4, 8, 16, 32, etc. It's always in powers of 2. So the last number here is going to be 1 times, in the place that it's in the 1, 2, 3, or I guess zeros, ones, twos, 3, so 2 to the power of 3. And we're going to add that. And then when we add all of these values together, so it's 1 times 8, right? Plus 0, plus 1 times 2, plus 0. And that will be, I think I have all this stuff in the way. That will be what? That's 8 plus 2, and that's equal to 10. And so this is our decimal value, and that's how you're going to convert it. I don't know if it makes sense. We're expressing it in actually a very similar way to how we do it in decimal. And you can do this with any different sets of numbers. Like if it was, we had 3 sets of numbers, you would do it in powers of 3. So these numbers here would become 3. And it kind of, if you think about it as representing the unique choices that you have for each specific slot in the number, it kind of makes sense. And if you had 11 unique digits, or for hexadecimal, you have 16 unique digits, which is 0 to 9, and you've also got A, B, C, D, E, and F, which represent 10, 11, 12, etc., up until 15. When you do this conversion, for example, let me put the 0x, meaning x means hex, so 0x. If I wrote the same number, well, seemingly the same number, I would have to instead, I can't just do it, I can't do the same calculation. I'd have to do the same thing, but instead of this 10 or this 2 here, it needs to be 16, because we've got 16 different unique digits we can do. So the way I'll do it is I'll do 0 times 6 or 15 right here. This is 16 times to the power of 0 plus, and then going to the left, 1 times 16 to the power of 1, and then left 0, I'm not going to write it out, and then 1 times 16 to the power of, so we've done 1, we've done 2, now it's 16 to the power of 3, and then what is this going to be equal to? Well, it's 16 to the power of 3 plus 16 to the power of 1, right? So that's going to be 16 times 16 times 16 plus 16, which you can add it all up, but that gives you a decimal value, and it's way, way bigger than 10, right? So the more unique digits we have, the more compact our number can be, because it's able to store more options per slot in the number. Does that make sense?
Yeah.
I don't know if, do you have any questions about this so far? This is just the main method to convert, direct from each one to decimal. You can always do it in this way.
Yes. Yeah, no, you explained it really well. I'll definitely have to replay the recording. I wouldn't want you to explain yourself again. But yeah, I need to make the options for this menu. You're explaining the formula to convert them, and now I just gotta make the menu with if and then statements, correct?
Yeah, so you'll have some functions that you're gonna have to make that are gonna do these formulas.
Got it.
Right.
Yeah.
In terms of the actual menu, just do an if statement. like you always do. And then in that if statement, then just call one of these functions that you make.
Yeah. And do you recall which week it was that Agrawal went over hexadecimals and binary?
I'd have to check. I don't really watch the lectures. Uh,
Okay.
I'm not totally sure. I've actually never seen him do a lecture, so I have to
Okay.
look for you.
No,
But
no. Okay. I'll catch up on lectures. I just yeah, I just haven't gotten there yet. That's all.
I can try and post like a short video. I mean, it's not too complicated, but it might be really hard to understand. I remember when I first learned this, I learned this in like a theoretical math class when I was in high school, and I didn't really understand. I'm like, it's so hard to comprehend counting in something that's not 10, you know? Like, oh,
Yeah.
after 10, I like, what do I do? And it's really weird. And like, oh, you're counting up to two. It's like you have one, two, and then you have to go up to the next thing. I mean, just imagine a hand with two fingers. That's kind of like what you're doing. It doesn't really
Yeah.
make much sense. So that's
Yeah.
why it's hard.
I know what you mean.
Um,
Yeah.
yeah. So I'll try and find some resources about it because it is useful. I mean, it's definitely useful, especially when you get further on, because a lot of stuff in the computer, you know, when you learn about computer design and stuff, it's all like written in hexadecimal because it can compact really huge numbers, right, into a smaller format. I don't know if you can actually see that here, right? Because you know, because it's storing with 16 unique digits, you can store more things.
Yeah. Yeah.
And
I know
so,
what you mean.
yeah,
I
so
I don't comprehend like 100%, but I'm like, I'm like on 90%. You know
okay,
what I mean?
well that's good.
Yeah.
I'll send out some resources hopefully,
Yeah.
and maybe that.